Now we move on to the model evaluation parameters. So on the right hand side you can see a table on which for a given binary variable z, which can have value 1 or 0, we have the actual values on this side and the predicted values on this side. So this table defines the counts in actual versus predicted scenario. So given the value of 1 as actual as 1, sorry, which means the actual value of z is 1 and we predicted it as 1, it will be counted as true positive value, counted towards true positive value. I mean, it can have some random value which is determined by this table. I'll discuss it later. So if it is 1 and the model predicted it as 0, it is false negative. And if it is 1 and model predicted as 1, it will be true positive. If it is 0 and the model predicted it as 1, it will be false positive. And if it is 0 and the model predicted it as 0, it will be true negative. So these all divisions determine counts for the model predictions versus the actual values. So each value is each predicted value counts in one of these divisions. So basically this diagonal here gives us the correctly identified values in 1 and 0, 2 positive and 2 negative. So what is true positive? It is correctly identified. And what is false positive? It is incorrectly identified. So true negative is correctly rejected and false negative is incorrectly rejected. Hope this is clear. So now we move on to the model evaluation parameter of accuracy. So accuracy determines the overall predicted accuracy of the model, and it is calculated as accuracy is equal to 2 positives plus 2 negatives divided by 2 positives plus 2 negatives plus false positive plus false negative. So basically the number of correct predictions, 2 positive plus 2 negatives, determined by the total number of predictions, whether it be 2 positive, 2 negatives, false positive or false negatives. That is accuracy. Now we move on to the relevancy scores. First one is the precision, which is the fraction of relevant instances among the retrieved instances. The precision is intuitively the ability of the classifier to not label a sample as positive if it is negative. So, true positive is the number of correctly identified positives and false positives is incorrectly identified positives. That is, actually it is 0 but we have identified it as 1. So if the real value is negative and we have identified it as positive, it comes under false positive. So it is saying that precision is intuitively the ability of the classifier to not sample a label as positive if it is negative. Basically false positive should be low. That is the precision determiner. The lower the FP here, the higher the precision. So I hope this is clear. Precision determines the fraction of relevant instances among the retrieved instances. So these are the retrieved instances in the denominator here, and out of that the relevant instances are 2 positives. The second one is recall or true positive rate. The fraction of relevant instances that have been retrieved over the total amount of relevant instances is termed as recall. The recall is intuitively the ability of the classifier to identify the positive samples. So recall is also known as true positive rate, which is recall is equal to Tp by Tp plus Fn, which is 2 positives divided by 2 positives plus false negatives. So 2 positives is this one And false negatives is when we have identified a true value as false, so that is false negative. But actually false negatives are also come under relevant instances, because relevant means one value. So false negatives plus true positive is the total relevant instances, which is the denominator here. Out of this we have currently identified this much, which is true positive, so that is the recall. It is the ability of the classifier to find all the positive samples. Next we have the true negative rate. True negative rate indicates how many negative values out of all the negative values have been correctly predicted. So this is basically from this row here, last row. So this is the actual total set of negative values. Out of this we have predicted only two negative as the actual. So that is the true negative rate, which is Tn by Tn plus Fp, which indicates how many negative values out of all the negative values have been correctly predicted. Next we have the false negative rate, which indicates how many positive values out of all the positive values have been incorrectly predicted. So this is the false negative rate, which is Fn by Fn plus Tp. So basically incorrectly predicted means for the one values. So out of all the positive values, which is this row here, how many have been negatively identified? That is the false negative rate. The lower the false negative rate, the better the model. Finally, we have the F1 score. It is a measure that combines precision and recall and is the harmonic mean of precision and recall. So F1 score is twice into precision into recall divided by precision plus recall. Basically, it is a parameter that determines how efficient our model is. Basically, it is the harmonic mean between of precision and recall. Receiver operator characteristic, or ROC, is another classification accuracy predictor. So it is used to determine the accuracy of a classification model at a user defined threshold value. So in the figure you can see the ROC curve. Next is overfitting and generalization. Overfitting is a common problem in machine learning where a model performs well on training data but does not generalize well to unseen data or test data. So overfitting is given in the last scenario here, where we are fitting more to the training data, which is given in red circles here, but plus is the set of test data, which is unseen data, and it is not fitting to the model. It does not generalize well to the model. So that is overfitting, when we are fitting our curve more to the test data. So basically opposite to it is underfitting, when we do not fit our data well to the test data. In this case it might fit well to the unseen data but not well to the training data, and some cases it might not even fit well to the other unseen data, suppose for here for example. So this middle value can be a good compromise. It is a value between overfitting and underfitting, which is also termed as best fit. So this is the best fit curve for this problem.